power controller for BLPM square wave DC motor. The power circuit for BLPM DC motor is shown in figure. This converter consists of six power semiconductor switching devices connected in bridge configuration across a DC supply. A suitable shunt resistance is connected in series to get the current feedback. The feedback diodes are connected across the device. The armature winding is assumed to be connected in stop. The rotor has a rotor position sensor and tacho generator is coupled to the shaft to get feedback signal. Control circuits. The control circuit consists of a commutation logic unit which gets the information about the rotor position and decides which switching devices are turned on, which is the device is turned off. This provides a six output signal, out of which there are used for base drive for upper leg devices. Then the comparator. The comparator compares the tacho generator output with reference speed and the output signal is considered the reference current signal for the current comparator, which compares the reference current with actual current. The rotor position sensor for BLBM motor. This position sensor converts the information from the rotor shaft position into the suitable electrical signal. This signal is utilized switch on, off and various semiconductor devices, electric switches and commutator circuits of BLBM DC motor. Two popular rotor sensors are optical position sensor and Hall effect position sensor. Then the next optical position sensor. This makes the use of six phototransistors. This device is turned on into on when the light rays fall on the devices. Otherwise, the device is off state in the schematic diagram shown. The phototransistors are fixed at the end shield cover such that they are mutually displaced by 60-degree electrically by a suitable light source. The shaft carries a circular disc which rotates along the shaft. The disc prevents the light ray falling on the devices. The suitable slots are punched in the disc into the state as suitable turns the main switching devices of electronic commuters. Then Hall effect sensor. A current is allowed to pass from the surface ABCD to the surface EFGH. Let the surface AB is subject to the North Pole magnetic field of flux density P Tesla. As per the Fleming left-hand rule, the position charge in the bellet gets concentrated near the surface ADHE and negative charge near the surface BCFG. Since the typeform material has three negative charges, the electrons gets concentrated near the surface BCGF. This charge distribution makes the surface ADR more positive than the surface CGF. Then the Hall effect position sensor. The Hall effect position sensor can be advanced than the BLDC motor. When the W1 carries the current on closing switch, S1 is set up north pole flux in the core. Similarly, S2 is closed to W2 energized set up the north pole flux. W and W2 are located in the stator such that axis 180 degree apart. A Hall effect sensor is influenced by the north pole flux. Then the Hall effect is made up of operate the switch S1. Then W1 is set up the north pole flux. The rotor experiences a torque and the south pole of rotor tends to align with the axis of W1 because of inertia. Then the polarity of Hall gets changed. This EMF makes the switch S1 is off state and S2 is closed. Now the W2 is set up on the north pole flux in the air gap. The rotor rotates in the anti-clockwise direction so that the S pole gets aligned with the W2 axis. Then the process is continuous. The rotor is continuously rotating.